Humanity, ignorant in bliss. We go about our lives unaware that in the depths of space lurk invisible monsters. Destroyers powerful enough to tear apart our sun and leave our Earth a shattered, burned-out ruin. You are about to enter the world of the universe's ultimate killer. We will be there when the monster is created, in the heart of a dying star. We will search for its telltale signs in the darkness of deep space. This is the story of the power that may one day destroy us all. The black hole.
There's an old saying, what goes up must come down. The thing is, it's not always true. If you throw something hard enough, it might never come down.
If something goes up fast enough, it can escape the Earth altogether. Faster still, and it can escape the immense pull of our sun, the force that holds the planets in place. In fact, travel fast enough and you can even escape the pull of the billions of stars that make up our galaxy. The Milky Way. But there is one object out there whose pull is so powerful you can never escape, no matter how fast you go. Not even if you travel at the speed of light. Meet the monster. This is a black hole in action. It is tearing apart a star that has strayed too close. Anything that comes near is destroyed.
It's hard to believe anything could be powerful enough to destroy something as big as a planet or a star, but it's true.
Let's take a closer look. Put a black hole near something and immediately it starts ripping it apart.
There's a star in there, could just as easily be our sun, and it is being pulled apart by a black hole. On this scale, our Earth would be no bigger than a pebble. We wouldn't stand a chance. The shocking thing is how small the black hole is. The black hole itself is right at the center of the disk. It's tiny. It's 1,000,000 times smaller than the star. Just look what it can do.
What is it about a black hole that makes it so powerful? The answer is gravity. It's the force that keeps us all stuck to the surface of our planet. If something's heavy enough, it pulls you towards it. And planet Earth is heavy. So heavy, in fact, that to get off it, you have to do this. All of this just to escape from our tiny globe. And if Earth's gravity seems strong, imagine the pull of the sun. Our sun is 1 million kilometers across. This is the real heavyweight of the solar system. But if you think our sun is big, think again. There are stars out there that are vast. Their gravity is mind-boggling. But compared to a black hole, even this star is a weakling. A black hole weighs as much as a massive star, but it's crammed into an area smaller than a pea. A black hole is gravity gone mad. Nothing can ever escape. What could create such a monster, something so heavy and yet unimaginably small? An event powerful enough to create a black hole should be clearly visible right across the universe. And recently we might actually have witnessed one, as it happened. It was a team in Australia, headed by Professor Brian Boyle, that spotted it. The first clue that led to his discovery came in the form of radiation, gamma rays, that are invisible to the human eye.
The night sky that we can see with our own eyes is only part of the picture. Light comes to us in many different forms, from low-energy radio waves to the most highest energy form of light, the gamma rays, the form of light that packs the biggest punch. Every night in the gamma ray sky is fireworks night.
We've been detecting violent bursts of gamma rays for decades, but we've never actually seen what causes them. It has to be a violent event, but what kind? The problem is gamma ray bursts only last a few seconds. To make things harder, the best way to detect them is from space.
Gamma Ray Observatory 2, Atlantis.
Atlantis, Houston, no need to respond. We're going to LOS. Teachers here in 30 seconds. We have two more minutes.
During a routine observation, the Gamma Ray Observatory detected an enormous blast of energy going off in deep space. What had triggered it? Brian Boyle's team, guided by the Space Observatory, turned their ground-based optical telescopes onto the blast in the hope of seeing it before it had time to fade.
The information was relayed down to the ground, and the optical telescopes sprang into action to try to localize where this burst of energy had come from. And what we found was something we didn't expect, that this light was actually coming from a supernova.
What they'd seen with their telescopes was an exploding star. but the explosion was far larger than anyone had ever witnessed before. And in the heart of that cataclysmic explosion, the researchers realized that something astonishing and terrifying had happened. As the massive star died, a monster had been born.
What we'd witnessed was the birth of a black hole.
What Boyle's team had seen was the death of a star so heavy that when it exploded, its entire mass collapsed inwards instead of blasting outwards into space. This star is absolutely huge. It's 100 times bigger than our sun, thousands of times brighter. It doesn't just explode. As its surface layers blast outwards, its core is smashed inwards. The center of the star collapses in on itself. Billions upon billions of tons of star stuff crushed smaller and smaller until the whole star is squeezed to a single microscopic point. And from the remains of the dying star, a black hole is born.
In our galaxy, a massive star explodes and creates a new black hole every 1,000 years. Which may not sound like a lot, until you remember that the galaxy has been here a very long time. Speeding up its history, you can see that stars have been going off like firecrackers. And when a black hole is born, it never dies. Every black hole that was ever created is still out there, so there should be around 10 million of them, somewhere. The question is, where?
Until recently, black holes remained unseen in the depths of space. But something as deadly as a black hole can't remain hidden forever. Like most predators, they leave a trail of destruction. And scientists are now beginning to recognize these telltale signs. One black hole hunter is John 11.
Even though black holes are dark and invisible, it doesn't mean they have no effects. They're extremely strong vortices, and they pull matter in these swirling winds around them, a lot like a tornado. And just like a tornado, you might not see it until the debris begins to get sucked up, like this tornado is now pulling the gases in it. And so suddenly you can see the presence of this vortex, this strong swirling wind.
It isn't the wind of a tornado you see, it's the havoc it creates. That's how we detect black holes too, by the damage they do.
Even though tornadoes are incredibly powerful, you don't see them until they suck stuff into them, until you see them pulling up cattle and houses and cars and gas and smoke and clouds. And it's the same thing with black holes. So you don't see them until they pull in the matter around them.
This is what astronomers look for. Not the black hole itself, but stars caught in the black hole's incredible gravitational pull. This one is tearing apart a star that drifted too close. A feeding black hole is anything but black. The whole star is wrenched out of shape as the monster tugs at it. Gas from the star whirls around the hole. It forms a super-hot disk of star debris 100,000 kilometers across. It's a deadly embrace that will last millions of years. And what the black hole can't swallow, it belches out. Huge jets of uneaten star are spat out into space.
Some of the most spectacular kinds of black holes we've seen are so powerful, they're drawing in so much material and spinning so rapidly that they create these huge jets, these powerful funnels of material. That are thin but incredibly, incredibly long, incredibly vast. And the jets themselves can cross as much as an entire galaxy. They're absolutely huge.
The damage a black hole inflicts on a star can be seen clear across the universe. Once astronomers knew what to look for, they began to hunt for feeding black holes. Using powerful space telescopes, we've tracked down more and more of them. And these are the actual images. Black holes tearing apart everything they meet. Most of them are remote. They're in distant corners of the universe. And we've only found them because they're feeding. But what about the black holes that aren't feeding? Where are the millions of black holes that should be wandering through our galaxy? They remain hidden against the dark background of space. Luckily, there is a way of tracking even the blackest of black holes. And this is what gives them away. Light.
A black hole's gravity is enormously powerful. It affects everything around it. It can even bend light.
So when a black hole passes in front of a distant star,
The light from that star is distorted.
and the black hole gives itself away. Finding a star at the precise moment it's distorted by a black hole is a daunting task. But that didn't stop one very, very patient astronomer trying to see the invisible. Tim Axelrod has dedicated many years of his life to the pursuit of the universe's hidden objects.
For the last 8 years, we've been looking at the same patch of sky every night, monitoring the brightness of 20 million stars. The reason that we're doing this is we're looking for microlensing events. These events are extremely rare, but they occur when a massive object passes across our line of sight to a distant star.
Axelrod set about his search for what he calls gravitational microlensing, when a star's light is distorted by a massive object like a black hole. But the odds were stacked against him. At best, his chance of finding the right star was 1 in a million.
That factor just seemed impossibly large to people, so most people thought that we would fail pretty dismally.
Undaunted by the enormity of the task and the skepticism of his colleagues, Axelrod set about looking for that one telltale pinprick of light amongst 20 million stars, every night for 8 entire years. Then one night, he hit the jackpot.
Here we have a view of the Large Magellanic Cloud. The blue square shows the field of view of our telescope. So now we've zoomed in a bit. The star which we're interested in is a pretty inconspicuous fellow right in the center of the crosshair. Now we zoom in yet again. This is picking the needle out of the haystack. And what we saw when we looked at it over a period of time was this. We were naturally ecstatic. Everyone that saw it agreed immediately that this was gravitational microlensing, so we were just over the moon.
Far out in space, he had seen the impossible. A massively heavy object like a black hole sliding silently in front of a distant star. Next, Axelrod turned to our own galaxy. What he saw was disturbing. Evidence not of 1 or 2 black holes, but hundreds. But is that anything for us here on Earth to worry about? Could our own fragile planet ever encounter one of these invisible monsters? If we do ever meet a black hole, it would tear our world to shreds. But one thing is sure. Our skies seem to be full of them. And our galaxy still has one last dark secret. And it took the most powerful telescope in the world to unlock it, the Keck in Hawaii. One of the astronomers using it is Andrea Ghez.
The Keck telescope is a fabulous telescope to use. It's great because it's large. This is a case where bigger is better. You get to collect a lot of photons so you can see very faint things, and it allows you to see very fine detail.
The telescope's vast mirror allows Andrea Ghez to study the center of our galaxy with more accuracy than ever before. And what astronomers have seen there is a black hole 1,000,000 times more powerful than normal.
Here's an example of one of the images we got just last night. We actually see that there are fainter stars towards the center of our field of view. And these stars are extremely important. The motion of these stars that revealed the presence of the black hole.
There is a black hole at the center of our galaxy that is so incredibly powerful it spins whole stars around itself at impossible speeds.
The fact that they're going 1,000 kilometers per second tells us there's 2 million times the mass of the sun of matter there.
This is no ordinary black hole. This black hole is a giant, 2 million times as heavy as our sun. And it's not in some far-flung region of the universe. This black hole is sitting right at the center of our galaxy. Suddenly, the idea that the Earth might one day fall victim to a black hole doesn't seem quite so unlikely. If we are ever unlucky enough to meet one, what would it be like? It begins far out in space, beyond the furthest planets. Unseen, a rogue black hole plows into the cloud of comets that surrounds our solar system and flings them towards Earth with incredible force. These impacts are the first warning of our fate. As the black hole comes closer, its next victim is Jupiter, the giant of our solar system. Even from so far away, the black hole's gravity makes itself felt here on Earth. Our world is being shaken apart. But the black hole hasn't finished yet. It's heading straight for the heart of the solar system, our sun. Though tiny in comparison, it tears the sun apart. Dragging the sun with it, the black hole heads towards Earth. The Earth is now unbearably close to the sun. All life has long since ceased to exist. And our planet starts to melt. Quietly, our battered world disintegrates and is consumed. And all that is left is the black hole drifting through space. Earth eaten by a black hole, it sounds bizarre. But we know that there are millions of these monsters out there. What we don't know is... Take a walk on planet Earth. It's a wonderful place. But don't take it for granted, because one day it might just vanish forever. This is the story of the universe we live in, and the dangers we face just by being here. We'll fly with the comets and asteroids which threaten all life on our planet. Here on Earth, we'll recreate our sun's headlong plunge around the galaxy and watch disasters unfold which could spell the end for us all. Our planet is under threat. Our mission is to stay alive. If you're a gambler, then this is the planet to live on, because just by being here, we're all taking a risk. And the odds are stacked against us. Do you feel lucky? You should do. You may not realize it, but we are all winners. We human beings are incredibly lucky to be here because the universe keeps trying to wipe us out. Trying and failing. We have survived every disaster the universe has ever thrown at us. So far. But our run of luck won't last forever. When it ends, our planet and our entire species will cease to exist. Unless we can do something about it. Could our whole planet really be in danger? What could threaten a globe 13,000 kilometers across, or 6 billion people? To understand the threat, you have to see it firsthand. I want to show you planet Earth as it was in its earliest days. This is where it all begins. We're lucky there's even a planet here for us to live on, because it was very nearly blown apart before life had even begun. This is planet Earth, billions of years ago, the very beginning of its life. As you can see, it is under attack. These are asteroids, rocks left over from the creation of the planets themselves. Some of them were vast, and one of them was on a collision course with Earth. This collision nearly smashed our Earth to pieces. We were hit by a ball of molten rock the size of Mars, traveling at colossal speed. The impact ripped huge chunks out of our planet. Somehow, it survived. But what about the future? Smaller chunks of rock are still flying around our solar system today. We call them asteroids, and they could put an end to human civilization. Asteroids range in size from pebbles to mountains, or even bigger. And they're dangerous. They're flying around at incredible speeds. To get an idea of the damage they can do, just take a trip to the moon.
4, 3, 2, 1, 0. All engine running.
Man, a species born and whose
lived all his life on Earth, moved with this journey out into the solar system.
There's really nothing to say about it. What can you say about a site like that?
You're a go to continue power descent.
In 1969, for the first time ever, human beings walked on the surface of another world.
Altitude 40,000.
The moon.
Tranquility Base here. The Eagle has landed. Roger, Tranquility, we copy.
And what a world it was. Airless, barren, hostile. And bearing the disturbing evidence of a terrifying threat. The moon is scarred with craters, the marks of countless asteroids that have slammed into it. The moon is under attack. And traveling through space alongside the moon is another planet, the one we call home. So why aren't we taking the same pounding? There's a simple answer to that. We are.
This crater was formed in a few seconds about 49,000 years ago. It's almost 1.2 kilometers in diameter. It's almost 200 meters deep. The object that caused it was an asteroid about 40 meters in diameter. Came in with a velocity of about 25 kilometers per second, and it exploded with the force of a 15 megaton hydrogen bomb.
This is Meteor Crater in Arizona. Geologist Jeff Wynn thinks that what happened here could happen again, soon.
Local effects would have been devastating. Obviously, anything within the circumference of the crater would have been obliterated. If you were an animal grazing within a few kilometers, you probably would have been killed by the impact blast. If you were beyond that, depending on where the wind was blowing, the ejecta coming down would have killed you. And this is just one rather blunt example of what could happen if one of these things did hit.
Geologists are discovering more and more evidence of asteroid impacts here on Earth. Meteor Crater would be hard to miss. Other impacts are more difficult to spot. But we have seen them. We've photographed them from space. These are the remains of titanic collisions, some of them vast, 20 or 30 kilometers across. The Earth is being pounded all the time. Siberia, 1908. An entire forest was flattened. There was an impact in Saudi Arabia in 1933. This was caught on camera in Canada in 1972. And near miss, it flew back out into space. If it had crashed on Earth, it would have exploded with more force than an atom bomb. Amazingly, in all these events, no one at all was killed. But even if an asteroid doesn't hit us, it could do something even more dangerous. It could hit the sea. If a big asteroid smashes into the ocean, it could create a huge deadly wave that could wipe out entire cities.
I think there's a realistic possibility that something like this could cause serious problems to human civilization sometime in the next century or two.
It's not an appealing thought, but the threat is real. Whole cities could be obliterated from space.
Whether or not it's your city comes down to luck. But before you feel too lucky, think about this. It may not matter which city you live in. There are things out there which could wipe all life from the face of the planet.
Space contains dangers that make asteroids seem utterly insignificant. Our telescopes have captured images of truly colossal disasters. This photograph shows a star 100 times bigger than our sun, blasting incandescent gas out into space. And this is a black hole, spewing out jets of superhot matter at close to the speed of light. If these had been near us, there's almost no chance that we'd have survived. It looks as though fortune has been on our side. At least it has, so far. But for how much longer? Professor Mike Rampino thinks the odds for long-term survival of life on Earth could be slim.
Luck probably plays a very big role in the existence of life on the planet Earth. You have to realize that the galaxy is a very violent place, and if we get unlucky, that could put an end to complex life on the planet.
Here's the problem. We don't notice it, but planet Earth is on the move. While we get on with our lives, the world is hurtling around our galaxy at 230 kilometers a second. And high speed means high risk. Some you win, some you lose. We may not realize it, but we're on the ride of our lives.
Think of the Earth's orbit as a kind of cosmic roller coaster ride. As we move in this orbit, we're moving past gas clouds. We can come close to black holes. Close to stars. We can come close to supernova explosions. Any of these objects could cause catastrophes on the Earth.
Sound incredible? It's very real. Life on Earth has been all but eradicated on 20 separate occasions. And to make matters worse, it's going to happen again.
After all, remember what happened to the dinosaurs. Flying through space is a dangerous business. It's not just that we're moving, it's where we're going. Planet Earth regularly flies through some of the most dangerous areas of the galaxy.
Well, if one could speed up time and watch the orbit of the Earth through the galaxy and around the galaxy, it would look like a very, very fast carousel. The sun and the planets moving up and down, and at the same time moving around the galaxy very rapidly. We go around the galaxy about once every 250 million years. But also, we go through the densest part of the galaxy every 30 million years. That's the danger zone.
Every 30 million years, our planet Earth travels through a region heavily packed with stars. And it so happens that it's every 30 million years or so that life on Earth comes close to being wiped out. Coincidence?
Here is our galaxy, a huge flat pancake of 400,000 million stars, all whirling around. The brightest areas are where the stars are most tightly packed. These are the danger zones. And this star is our sun. At the moment, it's just around there, just another pinprick in the cloud of stars that makes up our galaxy. But take a closer look and see how it's moving. It doesn't just go round and round the galaxy, it also goes up and down. And where the sun goes, the Earth goes. So, regular as clockwork, we plunge through the danger zone. And every time we do so, the odds are stacked against us. Here's how it works. This is our sun, and each of those other dots is a star. As our sun bobs up and down through the galaxy, we're passing them by the million. And where the stars are densest, the danger is greatest. The reason those other stars are dangerous is the powerful effect of their gravity on our solar system. Fly outwards from the sun, away from the Earth and the other planets, and eventually you encounter these. Chunks of ice, trillions of them, a vast cloud in space. If another star comes too close, its gravity disturbs the cloud and catapults ice chunks in towards the sun. More than 10 kilometers across, traveling at 40 kilometers a second, it begins its million-year journey into the heart of our solar system. We know these huge snowballs by another name. This is a comet. As it plunges towards the sun, it warms up and belches out a haze of gas and dust. An immense cloud trails through space behind it. The comet's tail. But this comet doesn't hit the sun. It skims round it and out.
That doesn't bode well for the future of the existence of human beings on the Earth.
We last passed through the danger zone 1 million years ago, but that doesn't mean we're safe yet. Because 1 million years is how long it takes for comets to make their way into our solar system. And in July 1994, one smashed straight into Jupiter, drawn in by its immense gravity. These blurred photographs reveal a colossal explosion. It covered an area bigger than our entire planet. If Jupiter hadn't intercepted that comet, if it had hit the Earth instead, it could have been the end of us.
I told you we were lucky. And it's not just that Jupiter saved us 6 years ago, it has saved us thousands of times. It's been doing so since the dawn of our solar system. Without Jupiter, life on Earth would never even have got started.
Remember all those asteroids in the early solar system? Back then, there were so many of them flying around that life couldn't even get started. What changed that was Jupiter. Its powerful gravity sucks in anything that comes too close. You're watching at 1,000,000 years per second. Jupiter made life on Earth possible. It drew the asteroids' fire and shielded our planet. It's still catching asteroids today. But unfortunately for us, the number of asteroids out there is all but limitless.
Sooner or later, our luck will run out, just as it did for the dinosaurs. Jupiter can't catch them all, and one is all it takes. This one, for example. The question is, what on earth are we going to do about it?
It seems we have a problem. This asteroid is huge, 50 kilometers across, 100 billion tons of rock surrounded by clouds of dust and debris. It's traveling at 40 kilometers a second, and it's heading straight towards Earth. So what are we going to do about it? The American military are on alert. The man who runs Earth's asteroid detection system is Sergeant Rob Medrano.
Today, comets and asteroids do represent the most significant threat that we have from space. Now, they do impact the Earth routinely, but mostly we're talking objects that are very small. What we're concerned about are those objects that actually penetrate the Earth's atmosphere in a large form. And with that in mind, on average, we're discovering about 4 a month.
The asteroid passes Mars. It is now only 45 days from the Earth. Already time is running out for us all. Detecting the threat is not enough. The point is to do something about it.
There are several possibilities. One is to send a rocket up with a nuclear device and blow it to pieces. Another possibility is to put chemical rockets on the object and literally try to shove it out of the way. This all requires that we have enough lead time to be able to mount some kind of a major project like this and do something about it.
two possibilities for human beings to survive far into the future. One is some kind of planetary protection. The other is insurance, moving off of this planet onto other planets. So if there are catastrophes on this individual planet, it wouldn't wipe out human beings entirely.
The potential still exists for an asteroid to impact the Earth that would essentially wipe out life as we know it. In terms of defending ourselves today, predicting where the asteroid is going to actually impact, that's really all that we have.
So far, we have survived. But what about the future? To safeguard that, we should be acting now.
One day, our planet's luck will run out. It's simply a matter of time. We must develop the technology to defend ourselves. Because if we're not prepared, the odds are that one day